Hi everyone, now you're watching my channel. All the content I create myself, new videos every day, so don't forget to like and subscribe. Your support means a lot. Thanks, bye!
Can you hand me that wrench?
Avery didn't look up, his hands deep inside the CNC housing, grease to his elbows. 4 in the morning.
Who are you? What are you doing here at this hour?
Avery looked up, a man in a dark overcoat, silver hair, cold eyes.
I'm just an intern, sir, trying to fix this machine.
12 engineers spent 3 days on that machine.
The man stepped closer.
They said it was dead. What makes you think you can fix it?
Because they were looking at the wrong part, sir.
The man stared at the young black man's oil-covered hands, at the notebook filled with hand-drawn diagrams, at the tools laid out carefully on the workbench.
That confident? Show me.
Avery had no idea who this man was, or that his life was about to change forever. Have you ever watched someone prove every doubter wrong with nothing but their bare hands? Because you are about to drop a comment and hit like, and let me take you back to where it all started. Brennan Aerospace sat on the east side of Cleveland, a sprawling complex of steel and reinforced glass surrounded by razor wire fencing. Inside, rows of bright white industrial lights turned night into permanent day. The plant never slept. 3 shifts kept the floor running around the clock, producing some of the most precise metal components in American manufacturing. The heart of the operation was a 5-axis CNC milling machine. It stood nearly 10 feet tall, weighed over 8 tons, and could carve turbine blades from solid blocks of titanium. Each blade had to meet tolerances thinner than a human hair. One machine, $2 million. And for the past 3 days, it had been completely dead. The CNC shut itself down mid-cycle 72 hours ago. The main screen flashed fault code E4421. The spindle froze. An unfinished turbine blade sat locked inside the work chamber like a fossil trapped in stone. Since then, 12 engineers had taken turns opening access panels, running cable-by-cable diagnostics, and debating the cause. They replaced signal cables, swapped sensor modules, reflashed the control firmware twice. Nothing changed. The machine refused to wake up. Every hour it sat idle cost the company more than $40,000 in lost production. Brennan Aerospace held a defense contract worth $300 million to supply turbine components for next-generation fighter engines. The penalty clause for late delivery had already started ticking. Somewhere upstairs, executives were recalculating the damage in real time. Down on the floor, the engineers were running out of ideas and running out of patience. Avery Fletcher was 19 years old. He came from the east side of Cleveland, from a block of small brick houses with chain-link fences and cracked sidewalks. He attended Cuyahoga Community College on a partial scholarship. One of his professors recognized his unusual talent for mechanical systems. She wrote a recommendation and submitted his name for the Brennan Summer Internship program. 3 weeks ago, Avery had walked through those factory doors for the first time in his life. His assigned duties were simple. Sort spare parts into labeled bins, wipe down tools after each shift change, run paperwork and supply requests between the factory floor and the front office. He wore the gray coveralls of an intern, a different color from the blue uniforms of the engineering staff. No one asked his opinion on anything technical. No one expected him to speak in meetings. His badge said, Intern General Support, and most people treated him exactly as that badge described. But Avery watched everything. During his lunch breaks, he stood near the CNC workstations and studied how the operators loaded machining programs into the controllers. He borrowed technical manuals from the break room bookshelf and read them cover to cover during bus rides home. At night, he drew diagrams in a small spiral notebook. He mapped the CNC's electrical architecture from memory, cross-referencing it with the manuals. By his 3rd week, he understood the machine systems better than some of the junior engineers who ran it daily. Craig Lawson was 50 years old and had been the chief engineer at Brennan Aerospace for 22 years. He managed a team of 30 engineers, controlled the entire technical operations budget, and reported directly to the vice president of manufacturing. When Craig made a technical decision on the factory floor, nobody questioned it. His word carried the weight of 2 decades of accumulated authority. Craig had opposed the diversity internship program from the beginning. He told anyone who would listen that it was charity work dressed up as corporate responsibility. He called it a waste of floor space. Kids with no degrees, no certifications, no real experience. They diluted his department. He resented every hour his staff spent on interns who would leave at summer's end. When Avery arrived, Craig looked at his badge, looked at his coveralls, and assigned him to the supply closet without a word. In Craig's mind, Avery was living proof of everything wrong with the program. A kid from a community college, no degree, no credentials, no business standing anywhere near a $2 million precision machine. The breaking point came in Avery's second week. He was walking past a quality inspection station when he noticed one of Craig's engineers entering calibration parameters into a testing rig. The tolerance values on the screen did not match the specification sheet pinned to the wall behind the station. Avery had memorized that spec sheet the night before. He stopped, hesitated, then spoke.
Excuse me, sir. I think that tolerance value might be off. The spec says .002, not .02. The engineer stared at him, checked the spec sheet, checked his screen. Avery was right. A decimal place error that could have passed defective parts through inspection. The engineer corrected the value without saying thank you, but Craig saw the whole thing. He stood 20 feet away. One of his engineers, a man with a master's from Ohio State, had just taken correction from a teenage intern. 3 other engineers noticed too. One raised an eyebrow, another smirked and whispered something to the man beside him. Craig's face went hard. He said nothing at the time, but from that moment forward, Avery Fletcher had a target on his back. 3 days after the CNC went down, Craig called a full engineering meeting in the main technical bay. All 12 engineers who had worked on the machine stood around a large whiteboard. The diagnostic readout from the CNC's last session was displayed on the wall-mounted monitor behind Craig. "The primary control board is fried," Craig announced. "We have confirmed it through every diagnostic channel available. The board needs a factory replacement from the original manufacturer in Stuttgart. Minimum lead time is 6 months." The room absorbed this in silence. 6 months. 300 million in contracts. A penalty clause already counting. Nobody had a better answer. Avery was in the room. He had been delivering a parts requisition form to the engineering bay when the meeting started. Protocol said he should have dropped the form on the desk and left. He did not leave. He stood in the back corner looking at the fault code on the monitor. He looked at his notebook. The numbers did not match Craig's conclusion. "Sir," Avery said from the corner. His voice was quiet but clear. I have been looking at the error logs. I think the problem might not be the control board. Every head in the room turned toward him. Craig's expression shifted. His jaw tightened. He walked toward Avery with slow, deliberate steps, his boots heavy on the concrete floor. "You think," Craig's voice was low and sharp, "you think you know more than 12 engineers who have been running diagnostics on that machine for 72 straight hours? No, sir. I am just saying that the fault code pattern—" "Shut your mouth!" Craig's voice cut like sheet metal. "You are an intern. You sort bolts, you fetch coffee, you mop floors. You do not open your mouth in a technical meeting. Not in my department. Not ever." The room was still. Avery's mouth closed. His right hand gripped the notebook against his thigh. Craig turned to face the room. "Since our intern has too much free time, let us put him to work." He pointed toward the corridor. "There is a mop in the west closet. The loading dock floor needs cleaning. That is your contribution. That is what you are here for." 2 engineers near the whiteboard laughed. A third shook his head slowly. One engineer in the back, a younger man named Davis, looked uncomfortable but said nothing. Avery did not move. His jaw was clamped tight. His eyes stayed level with Craig's. Then he did something that surprised even himself. He lifted the notebook, held it open so Craig could see the pages.
Inside were hand-drawn diagrams of the CNC's full electrical system, circuit paths traced in careful pencil lines, alt trees mapped out with arrows and margin notes. 3 weeks of quiet, methodical study. "I drew the whole system from the manuals," Avery said. "If we check the encoder—" Craig snatched the notebook out of his hand, flipped through 3 pages.
His eyes scanned the diagrams. The layout was detailed, labeled, and technically accurate. For one brief moment, something crossed Craig's face. Recognition, maybe? Or discomfort. Then it disappeared. He closed the notebook, held it out over the patch of oily concrete near the floor drain, and let it drop. The notebook landed face down in a pool of machine oil. Pages darkened instantly. 3 weeks of hand-drawn diagrams soaking through from the edges inward. "Your hands," Craig said, staring straight into Avery's eyes, "are only good for holding a broom. Do not ever waste my engineer's time again." The room went completely silent. Nobody laughed this time. One engineer looked away, another studied his own shoes. Davis in the back stared at the notebook on the floor with his lips pressed together. Avery stood still for 5 full seconds. His chest was tight. His fists hung at his sides, fingers trembling against the seams of his coveralls. He could feel every pair of eyes in the room. 30 people who watched a grown man humiliate a teenager and did nothing. Then Avery bent down, picked up the notebook, wiped the oil from its cover with his sleeve, closed it carefully, turned around, and walked out of the engineering bay without a single word. Avery learned to fix things before he learned to read. His grandfather, Earl Fletcher, was 72. His hands were like weathered oak, thick knuckles, permanent calluses, a grip that could crack a rusty bolt when a wrench could not. Earl served 20 years in the United States Navy as a machinist's mate 3rd class. He kept diesel engines running on destroyers that sailed through storms most civilians would never survive. He rebuilt turbochargers in engine rooms where the heat topped 130 degrees. When a pump failed at sea, there was no parts catalog to order. You fixed it with what you had, or you did not fix it at all. When Earl came home, he opened a small repair shop in his garage on East 116th Street. He hung a hand-painted sign that said, "Fletcher, fix it." The neighbors brought everything. Lawn mowers with seized pistons, outboard motors that sputtered and coughed, window air conditioners that rattled in their frames, portable generators that quit during summer storms when people needed them most. Earl fixed them all. He charged what people could afford, and sometimes that was a plate of food or nothing at all. Avery started going to the garage when he was 8 years old. At first, he just handed Earl tools and watched. He sat on an upturned milk crate and watched. His grandfather's hands moved over engines with a sureness that came from somewhere deeper than knowledge. But Earl was a teacher by instinct. He did not explain things with textbooks or diagrams. He taught with his hands and his senses. "Put your ear right here," Earl would say, pressing Avery's small head against the casing of a motor. "Hear that ticking? That is the valve train telling you it is out of adjustment. The machine is talking to you. You just have to learn its language." Earl called his method the 3 senses. First, listen. Every machine makes sound, and every sound means something. A healthy motor hums. A sick one knocks clicks or whines. Second, feel. Place your hands on the metal casing and read the vibration through your fingertips. A smooth vibration means balanced rotation. A rough pulse means something is loose, bent, or wearing out. Third, read the signals. Watch the exhaust color, smell the insulation, check the rhythm of a flashing indicator light. The machine is always telling you what is wrong. Most people just do not know how to listen. "Machines lie on their screens," Earl told Avery once, holding up a cracked distributor cap he had diagnosed by touch alone. "The sensors see what they are built to see, but sensors are blind to the things they were not designed to detect. Your hands are never blind." By the age of 10, Avery could take apart a small engine and reassemble it,
By 12, he was rebuilding carburetors, rewiring alternators, and diagnosing ignition faults that stumped adults who had been fixing cars for decades. Earl never praised him with big words. He would inspect Avery's finished work, nod once, and say, "Good. Now do the next one." The notebook started when Avery was 12. Earl sat him down at the workbench and handed him a blank spiral notebook. "Write down every machine you fix," Earl said. "What was wrong, how you found it, how you fixed it. Your memory is sharp right now. It will not always be. The notebook remembers when you cannot." Avery filled 3 notebooks by the time he graduated high school. Lawnmowers, boat engines, generators, air compressors, a commercial dishwasher from the restaurant down the street. Each entry was meticulous, diagrams drawn with a ruler, fault sequences written in his small, precise handwriting, repair steps numbered and dated. Earl never earned an engineering degree, neither had Avery. But Earl had a motto he repeated so often it became the rhythm of Avery's entire life. "Every machine wants to run. Your job is to listen to where it is crying for help." That sentence was written on the first page of every notebook Avery ever started. It was the first thing he saw every time he opened a fresh one. The notebook Craig Lawson had thrown on the oily floor was Avery's 4th. It contained 3 weeks of careful observations from inside Brennan Aerospace. Wiring paths, system flow diagrams, notes on fault codes he had overheard the engineers discussing at shift changes. On page 48 sat a hand-drawn schematic of the CNC's encoder assembly, the one section none of the 12 engineers had checked. Avery sat alone in the locker room that night. The notebook lay open across his lap. Oil still darkened the edges of the cover. He could see the smudge across page 12 where his diagram of the main power relay used to be clean. Most of the ink beneath the stain was still readable, not all of it. He thought about his grandfather, the way Earl's hands moved with a confidence that had nothing to do with credentials or titles, the way Earl never waited for permission to be good at what he did. He just walked up to the broken thing and fixed it. Avery closed the notebook, slid it into his back pocket, and made a decision. The factory floor at 2 in the morning was a different world. The day shift was long gone. The night maintenance crew had finished their rounds and retreated to the break room at the far end of the building. The overhead lights still blazed white. They never shut off, but the roar of production had faded to a low electrical hum. Conveyor belts sat motionless. Tool stations were wiped clean and locked. The CNC stood in its bay like a dark monument surrounded by silence. Avery badged through the side entrance. The security guard at the desk looked up, noted the gray coveralls and intern badge, and waved him through without a question. Interns sometimes came in early to prep supply carts. Nobody thought anything of it. Avery walked across the empty floor. His footsteps echoed off the concrete. He wore the same gray coveralls. His notebook sat in his back pocket, pages still damp at the edges from the oil. He carried a small canvas bag with hand tools, hex wrenches, screwdrivers, a pen light, and a shop rag. And a dial indicator he had borrowed from the calibration shelf that afternoon. Nobody had told him to come back. Nobody had authorized him to touch the machine. If Craig found out he was on the floor after hours, his internship would end before the sun came up. Avery understood the risk. He came anyway. He stood in front of the CNC for a full minute before touching anything. The machine towered above him under the white lights. The control screen was dark. The emergency stop button glowed red. Inside the sealed work chamber, the half-finished turbine blade sat exactly where it had been for 3 days, frozen, mid-cut. Avery opened his notebook to the page with the CNC's electrical layout. He had drawn this diagram over 4 nights, cross-referencing the break room manual with what he observed during shifts. He traced his finger along the circuit path. Power supply to control board to servo drives to spindle motor to encoder feedback loop. He flipped to his notes on the fault code. E4421, primary axis position fault. Every one of the 12 engineers had read that code and reached the same conclusion. The control board was sending corrupt position data. The fix was obvious: replace the board, standard procedure. But Avery had written a question in the margin of his notebook 2 days ago, underlined twice. A question that none of those 12 engineers had thought to ask. What if the board is reading correctly, but the data it receives is already wrong? He pulled a stool up to the base of the machine, pressed the auxiliary power button on the side panel. The diagnostic screen flickered to life, casting a pale blue glow across his face. He navigated through the menu to the raw sensor data page and let the numbers scroll. Axis positions, encoder pulse counts, servo current levels. Temperature readings across 6 zones. Everything from the control board looked clean: no shorts, no corrupted memory registers, no timing errors in the signal path. The board was performing exactly the way it was designed to perform. Avery leaned back on the stool, stared at the numbers scrolling down the screen. Then he stopped reading. He did what his grandfather had taught him to do first every single time. He put his hands on the machine. He pressed his right palm flat against the side panel just above the servo drive housing, closed his eyes. The metal was warm from residual heat in the auxiliary power circuit. He felt the faint vibration of the cooling fans inside the electrical cabinet. Steady. Normal. He slid his hand lower along the sheet metal toward the base casting. Normal. Then he moved to the headstock, placed both palms flat on the heavy iron casting that housed the spindle assembly. He held still, breathed slowly, let his fingers read what the screen could not show him. There. A faint, rhythmic pulse, not the smooth hum of a healthy bearing, something different, a tiny tick-tick-tick buried beneath the fan noise, barely perceptible through the thick casting. If the factory had been running at full volume, he never would have felt it. But at 2 a.m, in the silence, his hands found it. He opened his eyes, pulled the pen light from his bag and clicked it on. The encoder assembly was mounted on the back side of the spindle, behind a sheet metal cover secured by 4 hex bolts. Avery removed them one at a time, placing each bolt on the stool beside him. The cover came off, revealing the optical encoder. A glass disc slightly smaller than a silver dollar, etched with thousands of microscopic lines. A sensor head, positioned above the disc, read those lines as the spindle rotated. The data told the control board the exact angular position of the cutting tool at every fraction of a second. Avery aimed his pen light directly at the encoder mounting bracket. He leaned in until his face was inches from the assembly. And he saw it. The bracket had shifted, not dramatically, not enough to notice from arm's length, but under the focused beam of the pen light the displacement was visible. 2 mounting screws sat slightly off their original bore centers. The encoder disc was tilted less than 1/10 of a millimeter from its true alignment. He pulled the dial indicator from his bag, clamped it to the spindle housing with a magnetic base, touched the probe tip to the face of the encoder bracket, rotated the spindle by hand 1 full turn. The needle moved. 0.003 of an inch. Confirmation. Avery sat back on the stool. He stared at the encoder for a long, quiet moment. Then he looked down at the floor around the machine base. Black rubber scuff marks streaked across the concrete near the left side panel. A forklift had bumped into the machine, probably during shipment loading last week. The impact was small enough that nobody felt it through the building, but it was large enough to shift a precision mounting bracket by 0.003 of an inch. That tiny displacement was the entire problem. The tilted encoder fed the control board incorrect position data. The board compared incoming data against expected values, found a mismatch, and triggered fault code E4421. The safety protocol shut the spindle down to prevent the machine from cutting in the wrong location. Every engineer had followed the fault code to the control board because that was where the arrow pointed. But the board was innocent. It was doing its job perfectly. The real problem was behind a sheet metal cover that nobody had removed. Avery wrote everything down in his notebook. The dial indicator readings, the scuff marks on the floor, the encoder offset measurement. He drew the bracket assembly from memory and circled the displaced mounting screws. Then he paused, pen hovering over the page. He could stop here, report his findings in the morning, hand his notebook to one of the engineers and let the professionals handle the repair. But he heard Craig's voice in his head. "Your hands are only good for holding a broom." Avery looked at his hands, stained with oil, calloused from years in his grandfather's garage, the same hands that rebuilt a boat motor when he was 13, the same hands that rewired a restaurant's walk-in freezer compressor last summer and saved the owner $6,000 in spoiled inventory. He opened his tool bag, laid the wrenches out on the shop rag, and went to work. The first task was proving the diagnosis beyond any doubt. Avery powered the CNC into its full diagnostic mode. He accessed the manual axis control screen, which allowed him to move each axis independently and compare the commanded position to the encoder's reported position. He typed a command: "Move the X-axis exactly 1 inch to the right." The servo motor whirred. The table slid smoothly on its linear guides. The screen displayed the result position, 1.000 inches. But the dial indicator mounted on the machine table told a different story. It read 0.996 inches, a 3/1000ths discrepancy. For most machines in most industries, 3/1000ths of an inch was nothing. For a 5-axis CNC machining turbine blades to aerospace tolerances where the acceptable margin was measured in 10/1000ths, it was a catastrophic failure. Avery repeated the test on the Y-axis, dead accurate, the Z-axis, dead accurate, the A and B rotary axes, both within specification. The error existed only on the X-axis, the axis whose position was controlled by the encoder he had just examined. He sat on the stool and mapped the entire fault chain in his notebook, drawing arrows between each link. Step 1, a forklift impacts the machine base. Step 2, the impact shifts the encoder mounting bracket by 3/1000ths of an inch. Step 3, the shifted bracket tilts the optical disc off its true center. Step 4, the tilted disc sends slightly incorrect position pulses to the control board. Step 5, the control board compares the incoming position data to expected values and detects a mismatch. Step 6, the safety firmware triggers fault E4421 and shuts the spindle down to prevent the machine from cutting with incorrect position data. 6 steps, each one small, each one logical. Together they killed a $2 million machine and nearly cost the company a $300 million defense contract. And the reason 12 engineers with advanced degrees missed every single step was painfully simple. They trusted the fault code. The code said primary axis position fault. They went to the electronics, control board, servo amplifiers, signal cables, firmware. They never considered that the error might be mechanical. They never put their hands on the machine and listened. Earl Fletcher would have found this in an hour. Avery was sure of it. He remembered a day in the garage when he was 14. A customer brought in a table saw that kept tripping its circuit breaker. Avery checked the motor windings with a multimeter, normal resistance. He tested the power cord, no shorts. He examined the switch mechanism, clean contacts. Everything in the electrical system tested fine. He was completely stuck. Earl walked over without being asked, placed his palm flat on the table saw's base plate, held it there for 5 seconds. Then looked up. "Feel that? The motor mount bolt is loose. The motor vibrates against the housing. The vibration generates heat at the contact point. The heat breaks down the wire insulation where it passes through the housing. Insulation breaks down, current leaks, breaker trips. Nothing wrong with the electrics at all. The whole problem is one loose bolt." A loose bolt killing a table saw. A bumped bracket killing a $2 million CNC milling machine. Same principle, separated by 40 years and $2 million. The machine tells you where it hurts. You just have to be the kind of person who puts your hands on it and listens. The second task was the repair itself, and this was where Avery had to improvise. The encoder was not broken. The optical disc was clean. The sensor head was reading correctly. The problem was the mounting bracket. The impact had pushed it out of position. The mounting holes were slightly wallowed. The screws would no longer hold the bracket in its precise original alignment. Avery needed to compensate for the displacement. He checked the spare parts inventory on the nearby workstation terminal. Brennan Aerospace did not stock encoder mounting brackets for this particular CNC model. It was a specialized machine built by a German manufacturer, and replacement parts had to be ordered directly from the factory. Estimated lead time, 8 to 12 weeks. But Avery did not need a new bracket. He needed to shim the existing bracket back into alignment. A shim, a thin metal spacer placed behind the bracket on the low side, would push it back to where it belonged. The shim needed to be exactly 0.03 of an inch thick, no more, no less. He walked to the salvage yard at the back of the plant. This was the graveyard of old equipment, decommissioned CNC units with missing panels, retired lathes stripped of motors.
Aluminum extrusions from a tooling changeover last year. Avery knew this area well. Sorting and cataloging salvage parts was one of the first tasks Craig had given him during his opening week. It took him 20 minutes of searching before he found something useful, an encoder assembly pulled from a retired 3-axis CNC. Different manufacturer, different generation. But the mounting hardware alignment dowel pins and shoulder bolts was close enough in size to work as reference tooling for the realignment. He carried the salvaged parts back to the 5-axis machine, set them on the workbench beside his tool bag. Then he picked up a scrap piece of 6061 aluminum plate from the salvage bin. It was roughly 4 inches square and 1/4 inch thick. Far too thick for a shim, but it was flat, clean, and machinable. Avery marked the outline of the shim on the aluminum with a fine-tip scriber. He cut it out using a jeweler's saw, a thin-bladed hand tool designed for precision metalwork. The cut took 10 minutes of slow, careful strokes. Then he began filing. He held the aluminum piece against the edge of the workbench and worked it with a fine-cut mill file, long, even strokes. After every dozen passes, he stopped and measured the thickness with a micrometer, reading the barrel to the nearest 1/10 of a thousandth. File, measure. File, measure. The factory floor was silent except for the rhythmic scrape of metal on metal and the soft click of the micrometer's ratchet. Avery's hands were steady. His breathing was slow. He was not rushing. He was not nervous. This was the work he had trained for his entire life, even if he did not have a diploma to prove it. 40 minutes later, the shim measured exactly 0.03 of an inch thick, uniform across its entire surface. He checked it 3 times. Hold it up under the white lights to inspect the edges. No burrs, no taper, clean enough to satisfy a quality inspector. He placed the shim behind the encoder bracket on the low side, inserted the salvaged alignment dowel pins to lock the bracket's lateral position, tightened the mounting screws to the torque specification listed on page 43 of the maintenance manual he had memorized. Then, he reached for the dial indicator one more time. He mounted it on the spindle housing, touched the probe to the encoder disc, rotated the spindle slowly by hand. 1 full revolution. The needle barely moved. Total indicated runout less than 0.005 of an inch, well within the manufacturer's specification. Avery's hands were black with oil and fine aluminum dust. A small cut on his right index finger had opened up during the filing work, a thin line of blood mixed with the grease on his skin. He did not notice. He was not looking at his hands. He was looking at the dial indicator. It was perfect. The third and final task was the one that mattered more than anything, bringing the machine back to life. Avery replaced the sheet metal encoder cover, tightened the 4 hex bolts, wiped his hands on the shop rag until most of the grime was off. Then he walked around to the main control panel. He pressed the master power switch. The screen flickered on. The boot sequence scrolled through its initialization checks, cooling system active, hydraulic pressure building, servo amplifiers online. Each system reported in one by one like a crew calling roll. Then the moment came. The servo drives energized. The spindle motor started its warm-up rotation. The sound filled the empty factory floor, a deep, smooth hum that rose in pitch as the spindle hit operating speed. No vibration,
No clicking, no stuttering. Just the clean, powerful sound of a precision machine running the way it was designed to run. He initiated the automated self-test sequence from the diagnostic menu. The machine moved through its entire range of motion. X-axis nominal, Y-axis nominal, Z-axis nominal, A and B rotary axes nominal. Every position value came back green. Every temperature reading fell within the normal band. Every servo current trace was smooth and flat. The test cycle completed. A single line appeared at the bottom of the screen, all parameters nominal, ready for production. Avery stood alone in front of the machine. $2 million of equipment, humming quietly under the white lights. The turbine blade still waited inside the work chamber, ready to be finished on the next production run. 3 days of downtime, over $1 million in accumulated losses, 12 engineers and one $94,000 replacement board order, all of it unnecessary. The problem had been a 0.003 of an inch misalignment, solved with a hand-filed scrap of aluminum that weighed less than an ounce. He opened his notebook to the last unused page, wrote the date, wrote the machine model, wrote the fault code, wrote the root cause, wrote the repair procedure, drew the encoder assembly with the shim in position, noted the final run-out measurement, closed the notebook, slid it into his back pocket. Then he sat down on the stool and waited. He did not call anyone. He did not send a text or an email. He sat in the white light, hands on his knees, oil under his fingernails, blood drying on his index finger. Staring at the machine, 12 engineers declared dead. It was 3:45 in the morning. Harold Brennan built his company from a 2-car garage in 1986. He started with a second-hand lathe and a drill press he rebuilt himself.
His first contract was making valve stems for a local plumbing supplier. No degree, no investors, just hands and patience. 40 years later, Brennan Aerospace employed over 2,000 people and held defense contracts that kept fighter jets in the air. Harold was 62. Forbes had written about him twice. But old habits die hard. 2 or 3 times a month, Harold drove to the plant before sunrise. No schedule, no announcement. He walked the floor in work boots, checked the machines, talked to the night crew. He called it the only honest part of running a company. At 4 in the morning, Harold badged through the east entrance. The night security guard nodded without surprise. Harold walked toward the main production bay with a paper cup of coffee in one hand and his car keys in the other. He made it 15 steps before he stopped. He heard the CNC running. Harold knew that machine had been dead for 3 days. The production loss report sat on his desk in red ink. He had already signed off on an emergency purchase order for a replacement control board, $94,000 and 6 months of waiting. He had spent 2 nights calculating whether the penalty clause would cost them the entire contract or just most of it. But right now at 4 in the morning, the spindle was turning. He could hear the hum from across the bay, that deep, smooth, unmistakable sound. Harold set his coffee on a tool cart and walked quickly toward the CNC bay. His boots echoed off the concrete in the empty space. He turned the corner and stopped. A young man in gray coveralls sat on a stool in front of the machine. His hands were covered in oil and aluminum dust. A small notebook lay open on his knee. Behind him, the main control screen glowed green. All 5 axes displayed nominal status. The production readiness indicator was lit. Harold did not recognize him. With 2,000 employees, that was not unusual. "Who are you?" Harold asked. "Who authorized you to be on this floor at this hour?" The young man stood up. He straightened the front of his gray coveralls. He was tall and lean, and his eyes were steady despite the surprise of being caught. "Nobody authorized me, sir. My name is Avery Fletcher. I am a summer intern." An intern. Harold looked past Avery at the CNC screen, green across every parameter. He looked back at the young man's hands. Oil, metal dust, a cut on one finger. "My engineering team declared that machine dead. They told me the control board needed a factory replacement." "The control board is fine, sir," Avery said. "It was never the problem."
Harold set his keys on the workbench. Show me. Avery opened his notebook. He walked Harold through the entire diagnosis step by step, the fault code and why it was misleading, the forklift scuff marks on the floor, the encoder bracket displaced by 0.003 of an inch, the false position data feeding into a perfectly functional control board, the cascade that made a simple mechanical displacement look like a catastrophic electronic failure. He showed Harold the shim he had cut from scrap aluminum, showed him the salvaged alignment pins, showed him the dial indicator readings before and after the repair, pointed to the test results on the screen. Harold listened without interrupting. He had built machines with his own hands for 40 years. He understood every word Avery said. More than that, he understood what it took to see what 12 experienced engineers had missed. When Avery finished, Harold walked to the machine. He placed his hand on the side panel, felt the vibration. Smooth. Then he opened the encoder cover, looked at the shim Avery had filed by hand, ran his thumb along the edge. Precise. He closed the panel and turned to Avery. Where did you learn to do this?
My grandfather, sir, Earl Fletcher. He was a machinist's mate in the Navy. He had a repair shop in his garage.
And what did he teach you?
Avery paused. He taught me to listen to the machine before I look at the screen.
Harold stared at him, because he had heard those words before. Not those exact words, but the same truth behind them. 40 years ago in a cold garage with a used lathe, a young Harold Brennan had taught himself the same lesson. Trust your hands before you trust the readout. Feel the vibration, listen to the sound. The computer shows you what the sensors can measure. Your hands show you what is actually there. Harold looked at Avery's notebook. The oil stain spreading across the cover, the wrinkled pages. He picked it up carefully, turned to page 48, the encoder diagram that had led to the fix, studied it for a long moment. Why is this notebook covered in oil? He asked. Avery looked at the floor. He did not answer. Harold closed the notebook, held it with both hands for a moment, then handed it back gently, the way you return something valuable. Go home, he said quietly. Get some sleep. I need you in the main conference room at 9 sharp. At 9 o'clock that morning, the second-floor conference room was full. Craig Lawson sat at the head of the long table, coffee untouched in front of him. His 12 engineers occupied the chairs on either side, some with laptops open, others with printed diagnostic reports stacked in front of them. Avery stood near the door in clean coveralls, unsure whether he was allowed to sit. No one had offered him a chair. Harold Brennan walked in last. He did not take a seat. He stood at the front of the room near the whiteboard and let the silence settle for 3 full seconds before speaking. Avery, Harold said, come up here. Show everyone in this room what you showed me at 4 o'clock this morning. Avery walked to the whiteboard, picked up a blue dry erase marker. His hand was steady. He drew the CNC's encoder assembly from memory, the mounting bracket, the optical disc, the alignment dowel pins, the sensor head. Then he drew the fault chain. Forklift impact, bracket displacement, tilted encoder disc, corrupted position data, false fault code, safety shutdown. He wrote the measurement values. He explained the shim repair. He described how he confirmed the diagnosis using the manual access test and the dial indicator. The room was completely silent. 12 engineers watched a 19-year-old intern in gray coveralls explain clearly and methodically the problem their entire team had failed to solve in 72 hours. When Avery set the marker down, one of the senior engineers leaned forward in his chair. You found this by touching the machine? By touch first, Avery said. Then I verified with the dial indicator and the axis position test. No one spoke. Craig Lawson stared at the whiteboard. His face showed nothing. Harold stepped forward. Effective immediately, Avery Fletcher is transferred from the intern services pool to the engineering division. He will hold the title of technical engineering intern with full floor access and equipment authorization. Brennan Aerospace will fund a full scholarship for Avery to pursue a bachelor's degree in mechanical engineering at Case Western Reserve University. Tuition fees and books, for as long as he maintains enrollment. Harold looked directly at Avery. And when you graduate, There will be an engineering position at this company with your name on it. If you want it. Avery's hands tightened around the dry erase marker. His throat closed. He swallowed once, hard, and nodded. Yes, sir. I want it. Harold did not leave the room. He turned his body to face Craig Lawson directly. Craig, Harold said, let me ask you something. 12 engineers under your direct supervision examined that CNC for 72 consecutive hours. They reported to me that the primary control board was irreparably damaged and required a factory replacement from Stuttgart. Based on that report, I approved an emergency purchase order yesterday. Do you know what that board costs? Craig's jaw was tight. $94,000, sir. $94,000, Harold repeated, for a component we did not need, because the actual failure was a mounting bracket displaced by 0.003 of an inch due to a forklift impact, a mechanical fault, diagnosed and repaired by a 19-year-old summer intern using hand tools and a scrap of aluminum from our own salvage bin. The room was motionless. Engineers stared at the table, at the walls, at their own hands. No one looked at Craig. Craig opened his mouth to speak. Sir, the fault code pointed directly to the primary access controller. Standard diagnostic procedure dictates that you follow the fault code to its indicated source. Standard diagnostic procedure, Harold said evenly, cost this company 3 days of production downtime and over $1.2 million in losses. It nearly triggered the penalty clause on a contract that employs 800 people in this building. Your standard procedure told you what the computer said. This young man told you what the machine said. There is a meaningful difference between those two things. Craig closed his mouth. His fingers gripped the armrests of his chair. Harold continued, I spoke with several members of your team this morning before this meeting. One of them described an incident that took place yesterday afternoon in the engineering bay. During a technical meeting, Mr. Fletcher attempted to suggest that the fault might not originate in the control board. He was ordered to leave the meeting. He was told his only appropriate task was mopping floors. Harold paused. His voice remained level, but the weight of it filled the room. His personal notebook was taken from his hands, dropped in a puddle of machine oil, in front of the entire team. The same notebook containing the diagrams that led to the correct diagnosis. Several engineers shifted in their seats. Davis, the younger engineer, looked down at the table. Craig's face had gone pale. Is that account accurate? Harold asked. Craig took a breath. He is an intern, sir. Interns are not credentialed to participate in technical diagnostic. He is the only person in this building who fixed the machine. Harold let the sentence land. It sat in the silence like a dropped hammer. Harold placed both hands on the conference table and leaned forward slightly. I am ordering a comprehensive internal review of the engineering division's leadership practices and diagnostic protocols. The review will be conducted by an independent outside firm. It will assess how technical input from all team members is handled, regardless of title, rank, or employment status. He straightened up, looked at Craig one final time. You have been here for 22 years, Craig. That is a long time, long enough to know that this company was built by a man who started with no degree, no credentials, and no investors. Just a used lathe and a pair of hands that knew what they were doing. You should have recognized what was standing in front of you. You did not. Harold turned and walked out of the conference room. Craig sat alone at the head of the table long after the room emptied. The whiteboard behind him still showed Avery's diagram, the encoder bracket, the shim, the fault chain in blue marker. 22 years of authority, and now the walls were closing in. Not because someone conspired against him, because he looked at a 19-year-old kid with oil-stained hands and saw nothing worth hearing. The investigation would find what it would find. Craig knew there were other things buried in those years, shortcuts never followed. Junior engineers' concerns, filed and forgotten. He had built a department where only one voice mattered, and kingdoms built on arrogance do not survive the light. That evening, Avery called his grandfather from the parking lot of Brennan Aerospace. Earl picked up on the second ring. How is the job? Avery told him everything. The machine, the encoder, the shim he filed from scrap aluminum at 3 in the morning, the scholarship, the engineering seat. Earl was quiet for a moment. Then he asked the only question that mattered. Did you write it down? Avery laughed. Every detail, Grandpa. Good. That is all that matters. Avery looked at the notebook on his knee, oil stain on the cover, pages wrinkled from grease, but every diagram was intact, every fix was recorded, from an oily factory floor to an engineering future. One notebook, one pair of hands that never stopped listening. If you were Avery, would you have walked back into that factory at 2 in the morning? Drop your answer in the comments. If you caught the detail about page 48, you were paying attention. Like, share this with someone who needs it, and subscribe so you never miss these stories.
The story is over, but one thing keeps sticking with me. He didn't ask them to come. SQ showed up to that hearing expecting to sit alone, one man, one father, one chair. He had already accepted the squad he's to carry by himself, the way he carried everything else, quietly, without asking, but the room was already full. 147 people in the hallway, in the gallery, holding their receipts, not because he called them, not because he posted about it, because when you spend 2 years fixing a tower without asking for anything, the tower remembers. We treat generosity like a transaction, give and get, donate and deduct, have and wait for the thank you. SQ didn't fix that job road for a return. He didn't pay those roads for leverage. He saw broken things and had money to fix them. That's good the whole reason. He didn't build loyalty. He didn't build a network. He built a roof. And the loyalty built itself. That's the thing about generosity that expects nothing. You can't manufacture what showed up in that courtroom. You can't buy it. You can only earn it by never trying to. So, what is you fixing right now that nobody asked you to fix? Drop it in the comments. Share this with someone who needs this. And if you haven't subscribed, you already know.